Hey everyone, and welcome back to section 6.1. Let's get into some factoring. First, we want to review the distributive property, which is kind of fundamental to factoring. So remember that the distributive property says that A times the quantity B plus C is equal to AB plus AC, where A, B, and C are all real numbers. It also works with subtraction. But similar to in the last video, when I talked about how one side of the equation you're multiplying and the other you're factoring, it's the same deal with the distributive property. So going from the left-hand side to the right-hand side, you are distributing. Going from the right-hand side to the left-hand side, you are factoring. Factoring is, again, it's just a fancy way of saying that you're separating some you're breaking some big expression into the product of smaller ones. In particular, what we're going to be doing is taking the GCF of all the terms in a polynomial and factor it out. Here's a polynomial. First things first, I want to figure out what is the GCF of each of the terms in the polynomial. We're going to do this the same way that we did it in the last video. For 4x squared y, we have 2 times 2 times x times y. 10x squared y squared. Let's see, what do we have in common? There's one factor of 2. And no other common factors as far as the coefficients are concerned. We have one factor of x, and in fact a second factor of x, and that's it. So my GCF is 2 times x times x times x, or 2x cubed. Now that I have the GCF of the terms in the polynomial, I can rewrite it. And I do that by first writing the GCF in a set of parentheses. And each of the terms is just going to be reborn, so to speak, as what was left over from the factoring process. So for 8x cubed, it would be 2 times x, or 4x. For 4x squared y, it's really just the 2 and the y. And for the 10x squared y squared, we have a 5 left over and the 2 factors of y. And then we just put in the signs that we had before. And that's it. That's a factored polynomial. Let's look at some examples. So I'll first find the GCF. What do I have in common? I have a 3, one factor of x, and one factor of y. So altogether, this is going to be 3xy. And then what's left? I have x squared, 3xy, 2y squared. And put in my signs at the end. Same deal for the next one. Eventually you're going to get so good at this that you won't even need to do this bottom step here, where you list out all of the factors and you'll just be able to tell right away. and then put the appropriate signs in. All right, now here we could, if we really wanted to, distribute and then factor, but that's kind of a lot of work. So let's take a moment to notice that we have this y plus 7 as a factor in both terms. So if we wanted to, we could write this as something else. Let's call it maybe a. We then have 3y times a, which would be 3 times y times a, and for a, so that's what's in common. But really this a is y plus 7. So this y plus 7 can be thought of as one term unto itself. You can do the same thing with the second one. So this graphing here is very similar to just factoring out a monomial, even though these are binomials that we're technically factoring out. When we have something that's a little bit larger and we don't have any common factors among all of the terms, we can do what's called factoring by grouping. None of these terms here have any common factors, which is kind of a bummer. Or rather, they have no common factors that are shared by all 4 terms. Some of them have common factors though, right? Like, for example, xy and 3y have a common factor of y. 2x and 6 have a common factor of 2. So what we're going to do is treat those like they're individual expressions that we want to factor. If I factored what's in the purple brackets there, I have a common factor of y, so I'd have y times x plus 3. And over there, if I factor out my 2, I would have, again, x plus 3. And now we can do what we did in the previous example. That is, we can treat x plus 3 as its own term. And what's left over is y plus 2. And there we have it. All right, some more factoring by grouping that we can do. So here I have these first 2 terms have a common factor of x, and these last 2 terms have a common factor of -2. And there's more than one way to group these up. So you don't necessarily have to do this exactly the same way that I'm doing it. But all right, if we factor out an x from what's in the orange brackets there, I would have x times x plus 3. And generally speaking, if all of the terms are negative in an expression, we want to factor out that negative. And if we factor out that negative as well as the 2, everything is positive. Right, now we're back in familiar territory. What's left over is x minus 2. All right, one last example. Let's see here. If I break it up and group these 2 guys together, they have a common factor of x, and they also have a common factor of 3. These 2 have a common factor of 2. And I'm again going to factor a negative out when I factor out my 2. This is so I'm left with a positive 2x, which matches up with what I have here. And then I'll have a negative 1 here as well. All right, and we're off to the races, as it were. And then what is left over? 3x minus 2. So that's factoring by grouping. Again, practice makes perfect, okay? We gotta do a bunch of examples to feel more comfortable with factoring. Next up, we're going to be factoring trinomials, so it's a little bit more complicated. Yeah. Look forward to it, I guess.